Hey everybody, this is Larry. This is day 16 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem and today's video and all these things. We'll just go straight to the problem this time. I'm a little bit tired, I'm trying to take a nap, but I will do an extra problem in any case. But yeah, I don't know. It's just very cold here in New York. It is like 26 degrees, which is like -3 or -4 Celsius. And I just came back from running about 4 or 5 miles, something like that, and which is not that much, but it's so cold. I'm just not in shape for it, I guess. Trying to do it in a t-shirt, which also didn't help. But anyway, that aside, so I'm just trying to get this done. So let me know in the comments if anything is crazy. Today's problem is 380 insert delete get random of 1. So okay, let's see what this means. Implement insert a value. Is it like yes, it's set. Okay. Remove get random, get a random element from the current element. Yeah, I mean, I think there are a couple of ways we can think about it. How do we want to do it? I mean, I think remove is a little bit tricky as well. Average of 1, huh? So the get random thing, right? I think I guess average of 1 is not the same as. Okay, I think I have an idea. Okay, yeah. This is kind of a tricky one, actually. I think. I mean, it's only a medium, but I think a lot of the difficulties on the analysis, and the analysis is on the complexity, and average is really. Average is such a weird thing to say because it's not really a precise term, even though maybe it is what most people mean anyway when they say amortized, right? And amortization. I'm going to try something, and then we'll go over it in retrospect. But really, to be honest, just to kind of go over my thought process a little bit, it's just that I kind of tried a few things in my head to kind of see what worked. The number one thing that I wanted to do was the get random part, right? Get random to make it O of 1. You really an idea. Let me actually get a random thing real quick. I forget the exact the Python random yeah, I forget Python's random API is what I meant to say. Right, so you want to write something like this, like O of n, because then now you get a thing, right? So then from here, I'm like, okay, so you need a list of stuff so that you can kind of have random access, right? If you do anything else, any data structure where you do not have random access, this is not going to be constant time, and you might not even have, it might not even have, an idea about constant time because it may be a little bit messy. Okay, so what does this mean, right? So then now that means that I have to have an array, right? So that's why I was like, okay. So here I'm like, okay, maybe I have a self.array as you go to self and then then we could just do like n as you go length of self.array. Then we take, is this inclusive? Actually, I don't know. Inclusive. Okay. It's actually weird, but maybe not. I don't know if it's weird or not. But yeah, we take R as you go to do, and then we just return self.array of R, right? I mean, that by itself obviously makes sense, straightforward, easy. But now we have to do the thing, right? So self.insert, we would maybe have something like this, like append value. And then remove is maybe right? Remove val, something like that. I don't remember. But however, and it could be negative. Okay, fine. But yeah, obviously, is this a pen? Yeah. I mean, obviously there are a couple of issues here. This is not done, and I know that it's not done. Just to be clear, obviously this is going to be a set, so we need to fix this to be a set, right? So let's fix that real quick. So maybe we have like a scene type thing, we keep in a set, and then now we have self.scene dot add value or something like that, or like, you know, if value not in self.scene, then we add it, which is what we do, right? That's fine, right? And then we move over, it's gonna be the same with value not, if value is in scene, then we actually do removal, we do right? Is that right? I'm just running real quick just to get, I don't forget if this is called remove or something. Okay, it doesn't complain, so it looks good. Even though, gives me wrong answer. Oh, I have to return something with insert and force, I guess. Okay, so then now, so if it returns true if the item is not present. So that means, another way of saying this is return true if this is inserted. So that's what we'll do. So we'll just return true here and return false here. And then remove is if the item is present. Okay, yeah, so that means if the action is done, basically, right? So we, you know, okay, so we'll run it real quick, but there is a problem with this, right? This looks pretty reasonable, pretty good so far, but the problem is that of all these things, well, there's really only one thing that you need to worry about, which is the complexity. And of course, this, I mean, it's just initialization. Insert is going to be O of 1. This is O of 1. This is O of 1. We're happy. Removal. This is O of 1, but this is O of n, right? We have to find the index in which this is. We have to find the value in which this is in the array, and that's going to take linear time. So this is linear, right? And there's really no easy way to, I mean, you could really make, it's very easy to make a n, you know, n square thing, right? So this is nothing with amortization, because you could just remove the last element and it just goes through the list and then keep on removing the last element, then you get an n square thing, right? This stuff is all of 1, so that's fine. So how do we fix it, right? Well, one way that we can fix it is just, you know, instead of doing this operation, we only remove the value later on when we need it. So how do we do it? So, well, one is that we get rid of this, but then now here we may actually, you know, get something that is not in the value, or not, you know, not in the set. Now, how do we do it? So basically now maybe we get, you know, we do this. So maybe I'll do a while true just because, I don't know, maybe we'll change the conditional. Yeah, so then now if this is in self.scene, then we can just return this value. Otherwise, what do we do? Then if this is not in scene, that means that we remove this here, but we did not remove it here. So then now we can remove it here now, right? So that means that we can do something like self is equal to none, and then you kind of keep going. The problem, of course, is that this may go infinity, though it's not that bad, but it's just that, you know, you get empty spaces throughout, right? So like maybe you have like 1, 2, 3, 4, 5, and then, you know, you remove this, you remove this, or it's a none, I think, not a force, and then eventually, you know, this is going to actually like keep on looping pretty badly until you get a 1, 2, and a 5, which is, you know, no bueno. So the easy fix is actually just set this to the last element, and then pop the last element. And that's pretty much it. Unless it is the last element. But I think if this is the last element, it just doesn't do anything. So it should be fine. Yeah. And that should be good. Because eventually, well, I mean, this will only be true if self.scene is at least one element. I don't know if we need to worry about that. Oh, that's what they say. Okay. Let's give it a spin. Looks good. Let's give it a submit. So the question you might have is then, oh, well, in the past I've kind of struggled with this one, it seems like. So then the question is, well, how do you do the math of amortization, right? Well, the thing is that here in this removal, and you kind of fill in the, I don't know if I made that explicit or clear enough. When you do this, you actually fill out from the back, so then now you're trimming it size by 1, and there's no space in the thing, right? And the reason why this is that every time you run this loop, you remove one element or you return a good element, right? So that means that this loop will only remove one element, or will only loop the number of removed elements time, and that gives you that average or amortization here, because now for each value you want to remove, you will only remove it once. There is some like, I guess there is actually an edge case though. I have to be a little bit careful. Yeah, I think this is actually slightly wrong the way that I did it. Slightly inaccurate. And the reason is because I think you can like, the way that I did it anyway. So maybe I have to like keep the indexes instead. Maybe that's a little bit better. No, I mean, the reason is that you could remove and then add, and then this randomness would have actually multiple things. They did accept it, but this is actually a little bit inaccurate. So maybe we needed another thing, which is like used is equal to right? Or like maybe removed or something like that. And then here we can just is return false. And then here, man, we have to do way more kind of like tracking, because now we basically have to track we have to track the index. Maybe remove this isn't good enough then here. Maybe I could just do it as a set then. I'm a little bit lazy. I mean, there are a couple of ways you can handle this, but that's basically the idea. Here, maybe we append the length of the array, so then now this is the last element. I think maybe before we insert that. Oh no, but that doesn't, I kind of keep, you still need to use a reverse lookup. So yeah, you need to do a index lookup or something like this. Yeah. So then like maybe a lookup is equal to right? And then now, yeah, lookup is of the value is equal to length of the array, which is the last element to insert. And then here we want to self.lookup. Oh no, the lookup is fine. And then now we have to yeah. So basically, but basically we want to say that yeah, you have to handle the case where you remove this, but this is not removed yet, right? So so the insertion, we would actually have to, wow, for medium this is kind of like, I mean, I don't know, they kind of accepted something, but it definitely still a struggle, right? So if val is in self.lookup, then what does this mean? That means that we haven't removed the previous yet, right? So then now we can actually, if this is in self.lookup, we can add it back to scene. We can always add it to scene. This, we just don't do this. And we don't append, right? So if this is not in self.lookup, then we do this. And I think now this should be good. Basically now if this is in scene, we do. We also want to make sure that, okay, so it is in scene, then that means that's good. Okay, otherwise here we want to delete this, right? I guess I didn't really need this lookup then. Why did I do it this way? Oh, because I could do the index, but I don't need the index. I guess I just needed to do another thing, but I keep on confusing myself. This is kind of tricky. So maybe I could actually make this cleaner by doing it as remove, right? So this will contain contain things that should be removed but not yet, right? So then now here maybe we can change if this is not in self.removed, or if this is in self.removed, then we can remove it from the value. We don't need this anymore. And here is an else, because that means that if this is not in removed, then this is a new item, so then we can add it. Otherwise this is in the array already. And then here we do self.removed.add the value, and here we can actually do self.removed.remove this value. All right, give it submit. Yeah, that's a very small nuanced case, but it still is a thing. That's why it costs. What did I do last time? I am curious. I guess this thing is pretty idle. Remove is, the way that I did it last time was we removed, Maybe that way is easier, I don't know. Subdictionary and stuff. Insert, so it's already in there, we know, remove, then we remove the index. I guess this way is actually smarter, even though I did get a one-time error. Basically on remove, you just look up the index in which it is in the array, and then you push get it from the back. Wow, yeah, that way is made cleaner. So today, the way it works, but it is definitely way more complicated versus the last time I did it. So this is the code from last time. Definitely much cleaner. Basically on removal, you just, this is way cleaner. So this is the way that I recommend and not the way that I did it today. But yeah, this is all just going to be constant time. I don't even think there's any averaging here. That's why it's kind of pretty. It just kind of, you keep going. I think maybe I got confused by the averaging, or like the quote-unquote hint, and then I just try to average in. But yeah, so two ways to do this. But yeah, hopefully I kind of explained the dot process though, even though maybe I didn't quite do it, whatever, today. Let me know what you think. It's snowing here in New York tomorrow. It's going to be cold. I don't know, just take a nap. And yeah, that's all I have for today. That's all I have for this one. Let me know what you think. Stay good, stay healthy, good mental health. Have a great rest of the week. Stay safe. I'll see y'all later and take care. Bye-bye.